Welcome back to a new video. This is going to be section 1.4. We're doing part of 1.4 today. And so these are 1.4a notes. This is going to be our EOC review, and you'll be doing those in class. All right, so these are our standards. We are going to work with the angles in this section, and the construction that we're going to be working with is copying an angle. All right, as far as putting these standards in your notes, if you want to just put the part that talks about which standard it is, then that would be fine. This just lets you know, and your parents, if they're interested, that the standard was covered. All right, so we're going to talk about angles, and I know that you all have heard about angles in the past, and we're going to define an angle. We're going to talk about how an angle is named and labeled, and it's what forms an angle. So an angle is formed by two non-collinear. All right, so non-collinear. Collinear means unaligned. Non-collinear means not on a line, rays, that share a common endpoint. So here's our common endpoint, and that common endpoint E is called the vertex. And then the sides are formed by rays. So let's do some naming. So the expectation is everything that's typed is written on your notes, and everything that I write is written on your notes. All right, this angle is formed by ray EP and ray ET. So this is an opportunity to reinforce our one-dimensional vocabulary. Remember, a ray, the first letter of the ray is the endpoint. The second letter that's mentioned is a point it passes through. It's the order of these letters that tell you the direction, not the arrow. So we've got EP and we've got ET, and those are the sides of the angle. All right, so to name an angle, there's several ways. You can use 3 letters, where you use 1 letter on each side and the vertex letter in between the side letters. So P, angle PET refers to this angle. It's the same thing as angle TEP. TEP. The important part is E is in the center of the 3 letters because it is the vertex. So let me emphasize that one more time. The vertex letter must be in between your side letters, and the sides are the letters that are on the rays. Now, if there is only one angle at the vertex, then the angle can be named by its vertex. In the example up above, I could call that, and I should get a different color, I could call this angle P, or I should say above angle E. Now, if I were to draw this picture where this is A, B, C, D, we cannot use a single letter, not use one letter. This is why. If you try to talk about angle B, the question is, are you talking about angle A, B, D? Or are you talking about angle D, B, C? Or are you talking about angle A, B, C? You see, there's 3 angles at this one vertex. You cannot use a single letter. It's only when the angle's all by itself that you can use its vertex. Now, the third way that you can name an angle is if there is a number placed in the interior of the angle. And we got to define that word or show you what that means. A number can be placed in the interior of the angle near the vertex, and the angle can be referred by that number. So notice there's a 2 here. So I can refer to angle E, which we already said we could call it. I can refer to angle E as angle 2 because of the 2 that's right here. Now, the interior of an angle is the space between the rays, and these rays go on forever. So this area is infinite. The exterior of an angle is all the space that is not inside the angle, but outside the angle. So that's to help you understand what an interior angle is. All right, so if we look at this, I'm going to highlight in green. I'm going to highlight this angle. Okay, right there. Now, I can name this angle. I can name this angle A, B, C. I can name this, I want to use green. I want to color code this. Angle A, B, C. Or I could call it angle C, B, A, because B is my vertex. That means B needs to be in the center. However, I see that there's also a number 1 inside that angle, so I can refer it to as angle 1. What I cannot do is I cannot call it angle B, because there's the angle 1, the angle 2, and the large angle. All right, so now in blue, I'm going to talk about this angle right here, and I'm going to kind of do this so you can see the blue. And I'll use a blue pen so you know what I'm doing. So the blue angle can be called angle C, B, D. It can be called angle D, B, C, or it can be called angle 2 because it has a number. D, B, C, C, B, D. You should be able to take your finger, trace the angle as it uses the 3 letters. What can't be done is I cannot call it angle B because there's more than one angle at the vertex. All right, last but not least, let's look at this angle right here that's in pink. Okay, how do I label the angle in pink? So I could call it angle A, B, D. I could call it angle D, B, A. And those are my only choices. I can't call it angle 1 because angle 1 stops at that ray. I can't call it angle 2 because angle 2 stops at that ray. So those are the only 2 that I can do with the highlighter in pink. So now what I want you to do, and remember you highlight your U tries, I'm asking you to name name each of the 3 angles at least 2 ways. So when I talk about 3, remember this is 1 angle. Then your green angle looks like this. That's your second angle. And then your third angle in this case would be this one. So I need, and if you would group them like I did, so that you have the 3 together. Now what we're going to do is we're going to learn how to measure an angle with a protractor. So you should have a protractor at home. Please bring it to school because you're going to be doing this tomorrow in class. The measure of an angle is the smallest amount of rotation about the vertex from one ray to the other, measured in degrees. Now, next section, we're going to find another way to do our angles. There are 360 degrees in a circle, so a degree is going to be 1/360th of a circle. That's really small. All right, so if I have, let's talk about this definition a little bit. Here's my angle. All right, it said the smallest amount of rotation. And maybe I can get a rotator. Let me try to get one that I'll rotate. Here, I'll rotate this. I'll rotate my dotted line. So notice I could rotate this way, or I could rotate this ray up this way. And what this is saying is it has to be the smallest amount of rotation. This rotation is smaller than all of that rotation. This kind of rotation we say for trig class. This rotation is for geometry. So the angle, or the measure of this angle, is right there. That's what we would be measuring. All right, so how do we measure an angle? So we're going to place the center mark of the protractor For me, that's right here in the crosshairs. And we're going to take it and we're going to put that on the vertex of the angle. So I'm going to move my protractor over here, and I'm putting it on the vertex of the angle. However, that's not good. Now you have to line up the 0 mark, and notice there's 2 0 marks, of the protractor with one side of the angle. So I'm going to rotate, and I'm going to rotate over to here. And I think I'll try to, I'm going to keep that on my, all right. So I need to rotate this just a tiny bit more. All right, so as you can see, that center's on my vertex is on that center part of my protractor. They're all different. You got to look at yours. And I've lined up this ray along this side. Now notice the measurements of the protractor, I'll be able to measure from here up. You see, if I had, and I'm going to be sad about this, but if I had rotated here and stopped there, I can't measure my angle because my protractor is up here and not on the interior. So you got to make sure that your protractor is on the interior of your angle. Okay, there we are. So now the question, notice there's numbers. 10 corresponds to 170, 20 to 160. So you've got to pick. You either are going to read the inside or you're going to read the outside. So when you measure an angle, I'm going to measure from here to here. You start at 0. So because 0 is here, that means I'm going to be looking at the inside numbers. So when I come over here, it appears that I am just 1 degree short of 80. In other words, this is a 79-degree angle. It's that simple. Okay, the notation to refer to the measure of an angle looks like this. And this is real important. When you see angle ABC, it's really referring to the angle itself. When you put a little m out front, now that's saying the measure of angle ABC. Pretending that this is angle ABC, that is 79 degrees. So that is very, very important, that little m. Hopefully I got more to play with. All right, so here we go. I've got my protractor, and this looks different than the last one. So what I'm going to do is I'm going to put the vertex. So now this is my point that goes onto the vertex. I'm going to make sure that this side is lined up to 0. And now I've got to start at 0. It doesn't make sense to start measuring at 180. So 0, 10, 20, 30, 40 something. So it looks like I'm at 49 degrees. So this angle measures 49 degrees. All right, now another way you can do it, if we don't line it up on a side, and some of the problems in the book are going to be this way, and I'm sure on the test it's going to be this way also. Oh, wow, I didn't know I could change that. That's pretty cool, isn't it? Sorry. All right, so what we're going to do, a bit unconventional way, is to take the absolute value, this is like our ruler postulate, of the numbers that the rays pass through. So you have to make a decision when you do this. You either look at the inside numbers or you look at the outside numbers. So tell you what we'll do. We'll call this angle A, B, oh, I just messed it up. Oh, here, I can fix it. Okay, A, we'll call this B and C. So the measure of angle A, B, C is equal to absolute value. I'm going to use the inside numbers. This to, can't touch it. Okay, this to me looks like 20. So I'm going to say 20 minus, and this inside number is going to be 130. So that's going to be the absolute value of negative 110 or 110 degrees. Now, how else could I have done that? Well, I could have said the measure of angle ABC is equal to, now I'm looking at the outside numbers. This looks to me like 50 minus, I come over here, this looks like 160. So this is going to be the absolute value of negative 110 which is 110 degrees. But if you work with the outside numbers, you got to work with the outside numbers on this ray. If you work with inside numbers on this ray, you got to work with inside numbers on that ray. All right. I don't know, is there, So this is a U try. So, you know, you can't copy this off your computer. So this should be highlighted. This is a U try. I want you to draw an angle. Draw an angle on your paper, on your notes, and I want you to measure it. Measure with protractor. All right, so now we've got 4 types of angles. So we're going to have an acute angle is an angle whose measure is between, not equal to, between 0 degrees and 90 degrees. It's not 90, it's not 0. A right angle is an angle whose measure is 90 degrees. Not less than 90, not greater than 90, exactly 90. An obtuse angle is an angle whose measure is between, again it's the word between 90 degrees and 180 degrees. Not 90, not 180, but in between. Last but not least, a straight angle is an angle whose measure is 180 degrees. So that means when you have 2 opposite rays, one that starts here and one that goes that way, that is a straight angle. So now you have to classify each angle. And as we classify, we're going to find the measure. Okay, so if I do FMG, how do you do this? You put your finger on F, you go down to M, and then you go over to G. So we're looking at this angle right here. So if I want to find this angle is going to be the absolute value, it looks like, of 25 minus 90. And the absolute value of 25 minus 90, I believe, is 65 degrees. And because this is less than 90, it is acute. Now we're going to do angle DMG. So how do you find angle DMG? Take your finger, go to D. DMG, right there. So if I start at 0, 0's on the outside. I come up over, and that looks like it is 155 degrees. Because that's larger than 90, this one is obtuse. If we look at DME, where's DME? Again, I have to start at 0, so I'm on the outside. That is a 60-degree angle, and a 60-degree angle is less than 90, meaning it is acute. Now we've got to go into EMG. So here's E, down to M, over to G. So I'm going to look at the outside. So this is going to be absolute value of 60 minus 150, 160, 155. So that's going to be negative, absolute value of negative 95. Ooh, maybe that's 85. No, it's 95. Sorry, I'm not using a calculator. So let me make sure that's right. So that's going to be 5, not 15. All right, which is 95 degrees. Now that's bigger than 90, which means it is obtuse. Okay, so now we're going to look at HMF. So we start at HMF. That is 90 degrees, and because it's 90 degrees, it's called a right angle. So now it's time for you try. I want its measure, and then I want you to classify. All right, and this is where we're going to stop today. We have this one more piece. Congruent angles are angles with equal measure. Remember, we had congruent segments. They were segments with equal length. If you can work with congruent segments, then congruent angles are a piece of cake. So how do we show this? Angles they're angles. They're not. So we're going to say angle PWN is congruent to angle HEV. Notice the lack of measure. If I want to talk about the measure of angle PWN, then it's going to be equal to measure of HEV. Congruent means same shape and size. All right, so while we're here, I think it's good because I need to reinforce how to name an angle. I could have also said angle W is congruent to angle E, because there's only one angle at W and only one angle at E. Or another way is I could have said angle NWP is congruent to angle VEH. So that's our notation. Our marking is really, really important. How do we mark angles that are congruent? Here is what we do. We put little arcs through because those are single arcs. That means this is congruent to this. So now I need to see this word map, congruent angles. Define in your own words, again, own words. You own it when you do that. You're going to explain how to draw, how to label, and how to mark congruent angles and give example. Now, what is the relationship? And when I talk about relationship, I'm talking about a mathematical relationship. What's special about congruent angles? What is their mathematical relationship? Based on this mathematical relationship, when you are told you have congruent angles, sorry, there's a double S there. I truly do. I think I grouped it. So just ignore that S. Here, I'll just kind of take it away. So when you're told congruent angles, what do you look for? And how do you mathematically deal with them? If you answered this question for congruent segments, it's going to be very, very similar. All right, so if I want to do this, I want to draw, label, mark first. So I need to draw angle ham, and then I'm going to draw angle dog. Now, okay, that is the draw piece. Done. Now I'm going to go to the label piece. So H-A-M, that's been labeled. And now D-O-G, that's been labeled. Now the label piece is done. How do we mark the diagram to show congruence? We put an arc here, we put an arc here. Now it doesn't matter whether they look congruent. As soon as you see those marks, you know it is congruent. So now it is. So here I'm having you do this. I'm jumping to algebra. I don't think we're ready. Did I give you enough algebra information up here? Hold on, let me see. Oh, I did. So now I've got my picture drawn. So the next thing I'm going to do is I'm going to look at what they gave me. They told me that the measure, notice, now we're talking about the measure of ham is 4x minus 9. The measure of dog is 2x plus 19. All right, so what does congruent mean? When you see congruent angles, what are you supposed to look for? The definition says that their measures are equal. So you need to be able to justify this. What told you this? That was definition of congruent segments. Just kidding. Definition of congruent angles. So now you're going to subtract 2x. So you're going to have 2x minus 9 equals 19. We're going to add 9. So 2x equals 28. We're going to divide by 2. X is equal to 14. But did I ask you for x? I guess I did, but I did not say stop there. I need the measure of ham. So the measure of angle HAM is going to be 4 times 14 minus 9. Now, where did I get that? Right there. That's what ham is. So if I multiply 4 times 14, I have 56 minus 9. So the measure of ham is going to be 47 degrees. So now we're ready for a U-try. And you see, because we've already done congruent segments and all this algebra with segments, it makes this part a whole lot easier. So I need you to draw, okay, in case you forget, always, always, always draw, label, mark. You're going to draw, then you're going to label, then you're going to mark. And from there, you can complete it. That is the end of this lesson.